quantum computing creating the answer to this God molecule or this God equation, if this does happen, what would that mean to you, to a person who's studied this and been a scientist your whole life and the way you look at the world? How much would that change if there was some sort of a provable equation as to why things become ever more complex and universes exist and people exist? And
well, that's my childhood dream. As I mentioned, when I was 8 years old, everything changed in my life. A great scientist had just died, and all the newspapers said that he could not finish his final and greatest theory. And they put a picture of his desk on the news. The desk was open and unfinished. So I was fascinated by that story. That story changed my life because I said to myself, why couldn't he finish that theory? Why don't I try to finish that theory?
That's amazing.
So I went to the library and I looked up this man. This man's name was Albert Einstein. The theory was the theory of everything, an equation 1 inch long that would allow us to, quote, read the mind of God. These are Einstein's words. So I said to myself, that's for me. That's what I want to do for the rest of my life. So now we have the theory. It's called string theory. There have been TV documentaries on the subject, but it's not testable. So I think that a quantum computer may one day be powerful enough to test it in the memory of a computer. However, we have to be careful. Remember that novel, The Restaurant at the End of the Galaxy? What happened in that novel was the aliens of the future created a supercomputer to calculate the theory of everything, the ultimate theory. So the computer chugged and spit out the answer. And the answer was, the meaning of the universe was 42.
What is that?
So much for that. So I would hope that our quantum computer, computing on string theory, I hope would not give us the number 42 as the meaning of reality.
Maybe we're just too dumb to know what that means.
Yeah. But that's what motivated me.
Oh, yeah.
You know?
Well, that's a beautiful motivation. You just thinking about you being an 8-year-old looking at the photograph of Einstein's desk. That's amazing.
Yeah.
I love stories like that. I love origin stories because I've always wondered with someone like you.
Yeah, well, that changed my life. And then when I was in high school, I decided to take it one step further, and I decided to build an atom smasher, a particle accelerator in my mom's garage. So I assembled 300 pounds of transformer steel, 22 miles of copper wire, and I assembled a 6 kilowatt, 2.3 million electron volt betatron particle accelerator in my mom's garage.
In high school?
In high school, right.
Wow.
Every time I turned it on, I would blow out every single circuit breaker in the house. It consumes 6 kilowatts of power. My poor mom comes home, and she hears this pop, pop, pops out as I blow out every circuit breaker in the house. And she must have said to herself, why couldn't I have a son who plays baseball? Why not basketball? And why can't he find a nice Japanese girlfriend? How come he builds these machines in the garage? Well, that machine got me accepted to Harvard, and that began my career. As a theoretical physicist.
What were you able to do with that machine?
Well, I was able to create a magnetic field of 10,000 Gauss. That is 20,000 times the Earth's magnetic field. If you got too close to my machine, it would pull the fillings out of your teeth.
Really?
Yeah, so you had to be very careful.
What about objects that are close to it?
Scissors and things would
Hammers.
fly in the air, right? So you had to be very careful coming next to my machine.
Oh my God! So compare that to you can't even go near one of those scanners, those MRI machines, right? Magnetic resonance imaging.
That's right, MRI.
You can't have any metal near those, right?
Yeah,
but that's
right.
nothing like.
And they're about 10,000 Gauss too, about the same magnetic field as my machine.
Oh, okay.
So my machine is comparable to the machines that you see in the hospital today.
Wow. That's crazy. And you built that when you were in high school.
That's right.
Is that a photo of it? Well, that's a photo of one of those?
Yeah, that's the photo of it right there. You see on the left, you can see that's 22 miles of copper wire. You see the capacitor bank, a cloud chamber on the right where I photographed antimatter, because that was the whole experiment, to play with antimatter.
Wow.
And yeah, the cables are hooked up, and it's hooked up to 6 kilowatts that comes out of the wall socket. drained every single ounce of power from my mom's garage.
Wow.
Yeah,
look at young Michio. Look at you, you handsome fella.
Well, that's the Betatron particle accelerator.
That's amazing.
2.3 million electron volt generator of electrons.
So you were able to photograph antimatter with that?
Well, with the cloud chamber, yes, I was able to photograph the tracks of antimatter, tracks of positrons or anti-electrons that are emitted from sodium-22. And I proved that it was antimatter because they bent the wrong way in a magnetic field. Ordinary electrons should bend clockwise. These bent counterclockwise in a magnetic field. That proved conclusively that it was antimatter that I was photographing.
Wow. How old are you at the time?
Oh, it's about 17.
I was so dumb. I'm pretty dumb now, but I was so dumb when I was 17. That's amazing thinking you were spending your time doing this.
Right.
I was listening to Led Zeppelin.
But, like I said, I was chasing after this dream of an 8-year-old child wondering, is there a theory of everything?
It's an amazing dream.
Yeah.
Now, where did you get the designs for this?
Oh, well, these designs come from an X-ray machine done by Donald Kirst, who was one of the inventors of the Betatron. Most hospitals have one that creates X-rays for patients.
So was there a schematic online that you duplicated? Did you devise this yourself?
No, there was a schematic online. I mean, there was no line back then. In the library.
Course, online. Excuse me.
In the library there was a schematic, but I had to fill in the details. I had to do the equations to calculate how many turns of wire, how many Gauss. I needed 10,000 Gauss in order to bend tracks of 2.3 million electron volts. All the calculations had to be done ahead of time to make sure it would work.
Isn't it funny that the universe is so common the internet rather, is so common that I automatically for a second forgot that we were children when you were younger than me, or when you were younger.
That's right. There was no internet.
There was no internet at all.
Nothing online back then.
It was just books.